Lesson 4, rational equations, is our last lesson on rationals. So in our first three lessons, we dealt a lot with rational expressions, and you know that rational expression has no equal to sign because rational expression is not a full equation. So, but in this lesson, we will be dealing with equal to sign. There are steps for solving rational equations. Step number 1 is factor everything if possible. Step number 2 is list the non-permissible values. And you know that non-permissible value is the value of the variable that makes the denominator of your rational expression equal to 0. And the rational expression with the denominator 0 is not defined. Step number 3 is determine the least common multiples for the equation and write each term with it. Step number 4 is simplify each side of the equation to a single rational expression. It means that if you have two or more than two rational expressions on one side of the equal to sign, you simplify them either by adding or subtracting and make them as one rational expression and then simplify your question. Step number 5 is equate the numerator of each side by cancelling out the denominators because they are same. Step number 6 is solve for x, and step number 7 is verify your solution. So let's do a few questions. So question 1 is x divided by 3 plus 5 divided by 2 is equal to 5x plus 6. So you can see that there are two rational expressions on the left side of the equal to sign. We're going to solve these two rational expressions as one rational expression and then simplify for x. To do that, we need to have our same denominator. So here in our denominator, we have 3 in the first rational expression and 2 in the second rational expression. Okay, and on this side of the equal to sign, on the right side, we have 6 as our denominator. So we're going to find the LCM of 3, 2, and 6. So LCM of 3, 2, and 6 is 6. And I'm pretty sure you know how to calculate the LCM. To do that, you have to write the multiples of 3. Multiples of 3 are 3, 6, 9, and so on. Then write the multiples of 2. They are 2, 4, 6, and so on. And multiples of 6 are 6, 12, and so on. And the first common multiple is 6. So therefore, the LCM for 3, 2, and 6 is 6. Now let's simplify. So here, in our first rational expression, we have 3 in the denominator. So what should I multiply this 3 by in order to get 6? It is 2, right? So we will multiply this 3 by 2 in order to get our LCM, that is 6. So I will multiply our numerator also with the 2. So in the numerator, I will get 2x. Now we will solve our second rational expression. So we have 5 by 2. So I'm going to multiply this 2 by 3 in order to get 6. So I will multiply my numerator also with the same factor, that is 3. So 5 times 3 is 15 and 2 times 3 is 6. So on the right side, we have 5x by 6. Now, left side, we will have 2x by 6 plus 15 by 6 equal to 5x by 6. So here, we have common denominator, that is 6 on the left side. So I can write this 6 as as a 1, 6, and then just simplify my numerators. Okay, now this 6 and 6 cancels out because they are same. So I will equate my numerators and simplify for x. So we will subtract 2x on both sides. So 15 equal to 3x, and solve for x by dividing by 3 on both sides. So x is equal to 5. So we got the value of x. Now we're going to verify this. To verify, we'll take x equal to 5 and plug it in both left side of the equal to sign and on the right side of the equal to sign. Okay, so take x equal to 5 And we'll put on the left side. So this becomes 5 by 3 plus 5 by 2 is equal to 5 times 5 by 2. So on the left side, we have two rational expressions. We're going to simplify them and to make one rational expression. So here our denominators are different. So we're going to find the LCM of 3 and 2. The LCM of 3 and 2 is 6. Okay, so here is 6, sorry. So I'm going to multiply this 3 by 2, and I will multiply this 5 also by 2. So this becomes 10 by 6. And the second expression I will be multiplying the denominator by 3 and the numerator also by 3. This becomes 15 by 6 equal to 25 by 6. So here we have the same denominator, so we will simplify the numerators. So 10 plus 15 is 25. So 25 by 6 is equal to 25 by 6. So our left side is equal to right side, hence verified. So let's do question number 2 now. So in question number 2, on the left side of equal to sign, we have three rational expressions. We're going to solve them and make them as a one rational expression. Okay. To do that, we have to find the LCM. So LCM of 5, 15, and 3 is 15. Okay. So let's simplify our left side first. So our denominator here is 5. So I will multiply 5 by 3 in order to get 15, and I will multiply the numerator also by 3. So this becomes 3x by 15. And the second expression, I will not do anything here because it's already 15 in the denominator. And third expression, I will multiply denominator and numerator by 5. So we will get 15 in the denominator. And here, so here again, this is 1, right? This 1 means 1 by 1. So I will multiply the numerator and denominator by 15, and this becomes 15 by 15 plus, and this x, I will multiply the numerator by 15 and denominator by 15, and it becomes 15x by 15. So on the left side, we have the same denominator, that is 15. I will just write the numerators together, and same thing I will do on the right side. Okay, now this 15 and 15 cancels out because of the same denominator. So I will just equate the numerators. And then simplify for x by combining the like terms. Now here 3x plus 5x becomes 8x plus 8 equal to 15 plus 15x. Now I am going to subtract 8x on both sides. And then there's plus 15, so I'm going to subtract 15 on both sides. This 15 and 15 cancels out, positive 15 and negative 15. And here positive 8x and negative 8x, they both cancel out. So here 8 take away 15 is negative 7 equal to 15x minus 8x is 7x. Now I will divide by 7 on both sides, then I will get x as negative 1. So we got the value of x as negative 1. Now we're going to verify this by plugging the value of x as negative 1 in our main equation. So when you plug x as negative 1 on the left side, and then you simplify this entire thing, you will get 0 as the answer. And when you plug x as negative 1 here, right here, sorry, so plus 1 and negative 1 is 0. So our left side is equal to right side, hence verified. So now we're going to do our question number 3. So in question number 3, we have x plus 9 divided by x plus 6 equal to 4. So x can be written as x by 1, right? So now our LCM here is x plus 6. So in the first rational expression, that is x by 1, I will multiply the numerator and denominator by x plus 6. So I will get x into x plus 6 divide by x plus 6 plus 9 divided by x plus 6, and this 4 also I will multiply and divide by x plus 6. Now you can see that our denominator is same on both left side and right side of the equal to sign. Okay, now let's simplify for x. So here I can write the left side as x plus 6 in the denominator, and the numerators I will write them together. Now this x plus 6 and x plus 6 in the denominator, they cancel out, and we will just equate the numerators. And now we're going to simplify this to find the value of x. Let's open the brackets. So x times x is x squared, and x times 6 is 6x. And on the right side, we have 4x plus 4 times 6 is 24. Let's combine the like terms. So we're going to subtract 4x on both sides and then subtract 24 on both sides. Okay. Now let's solve this. So we get x squared, 6x minus 4x is plus 2x, plus 9 minus 24 is negative 15, equal to 0 on the right side. Now we got a quadratic equation. Let's find the factors of this quadratic equation and then solve for x. Factors of this quadratic equation are x plus 5 and x minus 3 equal to 0. If the product of two things is equal to 0, it means that either x plus 5 equal to 0 or x minus 3 equal to 0. So we'll get x plus 5 equal to 0 or x minus 3 equal to 0. So from here, we'll get the values of x as negative 5 and positive 3. Okay. Now, we're going to look for our non-permissible values because we have a variable in the denominator. So in first two questions, we didn't have to find the non-permissible values because there were no variables in the denominator, right? So now, but in this question, we have to find non-permissible value because of the variable in the denominator. So non-permissible value here is, so our denominator here is x plus 6, right? If I plug the value of x as negative 6, then my denominator will be 0. So I will say that the non-permissible value is x should not be equal to negative 6. Okay? Now, we got our two answers for x, right? Negative 5 and 3. We're going to verify these two answers by plugging them in our main equation and then see if left side is equal to right side. Because if one of these roots will not satisfy our condition, right? And then we will say that that is an extraneous root. Okay? So we have